Spark cluster operations. Spark cluster management methods include a standalone, Yarn, and Mesos. And the features of the Spark Central Master, the executor's initiation, and task execution are listed right here. And I will explain this in further detail. But before we go into cluster management, let's once again review the Spark operation. Here is the scheduling hierarchy. Spark cluster schedulers are Yarn, Mesos, and the standalone. And once again, we have RDD and libraries. And also the DAG scheduler divides the DAG into stages, which is divided into multiple tasks that run in serial and parallel modes. The task scheduler processes the task within each stage, and the executor processes the threads using the cores. Spark scheduling process example starts with multiple RDD objects to be processed through stages of transformations through the DAG. These transformations are lazy until an action is executed. The job will start to run multiple stages, both in serial and parallel. And in order to do this, it will look through the overall DAG and prepare a scheduled plan. Each stage will execute multiple tasks in parallel, and a parent RDD will result in a child RDD after the DAG is operated, where each task will result in a new child partition to form the overall output RDD. Here, the operation now goes into action where the Spark driver JVM will use the DAG scheduler to divide the entire DAG into stages. Each stage is assigned a task to the scheduler. The task scheduler will assign tasks to an executor to be processed. Then the task scheduler will use multiple executors to process multiple tasks in parallel. The executor will process tasks using threads to its cores that it has. Executor block manager will serve blocks of data and store processed outputs. When the task scheduler is done processing the overall stage, the task scheduler informs the DAG scheduler that it is done. If unprocessed stages remain, the DAG scheduler will assign additional stages to the task scheduler for processing. When all stages of the job are done, the child RDD will be stored. Based on that, now, once again, let's look into the details of standalone, Yarn, Mesos, which are the cluster management schemes and how they actually work. We will start with Spark standalone. The Spark master will set up on one node. Workers will be set up on multiple nodes in the cluster. Then, the Spark master and workers are JVMs, which have relatively light processing burdens. App 1 will initiate driver 1 to run on a selected node. Driver 1 will run job 1, which is the job of app 1, and will communicate with the Spark master, which is the scheduler, that will schedule execution of job 1. The SM will tell selected workers to process the task of job 1 on their executors, which are JVMs. A job is made up of multiple stages. A stage is made up of multiple tasks. The executors will be assigned multiple RDD partitions to process the tasks based upon app 1's DAG. Each executor identifies multiple cores on its node to be used in processing app 1's threads. Then, the multiple threads are each assigned to a core, or maybe using or sharing a core for simultaneous parallel processing. What if application 2 is now newly added and it runs on the same executor as app 1? Then, app 2 will initiate driver 2 to run on a selected node. Driver 2 will run job 2 and communicate with the Spark master that will schedule execution of job 2. The SM will tell selected workers to process the task of job 2 on their executors, JVM. The executors will be assigned multiple RDD partitions to process the task based on app 2's DAG. and each executor identifies multiple cores on its node to be used in processing app2's threads. Now, here is an example which I animated of the explanation I just gave to you. So watch this in an animated structure. Number one, in the standalone example, selected nodes of the cluster have these nodes selected. Then a Spark master is initiated. The Spark master will set up workers on these nodes. The workers will set up executors on these nodes. And the executor will need cores to execute something, right? Then, for RDD1, there is partition 1, partition 2, partition 3 on the leftmost worker, executor. Then we have partition 4, 5 on the second one, partition 6, 7, and 8 on the third one, and then we have partition 9, 10, 11 assigned. Then, all of the tasks that need to be executed, once again, there is a job divided into stages, and the stages have multiple tasks that run in parallel and serial on the executor, and these are the tasks. Then, threads will form from these tasks to enter the cores. Now, I know that the threads are not really threads that we use in thread and a needle to sew clothes, but anyway, I drew them as threads to show them entering the cores. Then, if you had another job that needs to be executed, then from RDD2, there is partition 1, 2, partition 3, 4, 5, and 6 and 7 assigned to the executors on the multiple nodes. Now, these RDDs, of course, will have a job assigned, which will be divided into individual stages, and the stages will be divided into multiple tasks, and these tasks in serial and parallel will be executed through threads to be executed on the cores. Now, in comparison, what if App 1 and App 2 are running on different cores? Then something like this would happen, where App 2 will initiate driver 2 to run on selected nodes, and driver 2 will run job 2 and will communicate with the SM that will request for workers of selected nodes to set up new executors for job 2. Then the SM will tell the selected workers to process the tasks of job 2 on their new JVM executors. The new executors will assign multiple RDD partitions to process the task based on apps 2 DAG. Each new executor identifies multiple cores on its node to be used in processing apps 2 thread. For example, let's assume that we have executors already here, and already our app 1 is using these executors. Then we have a new executor assigned to each one of these nodes, and each of these executors, of course, have cores assigned to them. These cores will be independent of the cores that were assigned to the App 1 job. These cores will be used for the App 2 job. Then we have the RDDs, and then the stages are divided into tasks, and these tasks have threads that run in their cores, where each partition of the RDD, 1, 2, partition 3, partition 4, 5, and partition 6, 7 are assigned to the cores. Resilience to failure for crashes that may happen. Executor crash is recovered by the worker, which is the stage above. The worker crash is recovered by the SM, the Spark master. If the Spark master crashes, well, that's where Zookeeper, high availability, the backup engine, will kick into action and will make us resilient from this crash failure. The SM is replicated on another node in the cluster for backup. And multiple SM backups can be made to make this more secure and reliable. More SMs can be added during the job execution if needed. So you can add them in the middle of the process if you feel that you need more. Spark Mesos. A Mesos-based Spark cluster. In standalone mode, the cluster manager is the Spark master. When Mesos is used with Spark, the cluster manager is the Mesos master. Mesos was designed to support Spark. Advantages of using Mesos include dynamic partitioning between Spark and other frameworks running in the cluster. In addition, very efficient and scalable partitioning support between multiple jobs executed on the Spark cluster. Comparing Spark cluster operations to a Mesos-based Spark cluster operations, first, you can see the components of how Spark would do it and interact with cluster management in the middle. Compared to this, in Mesos, it has its own master and workers. And inside the workers are where the Spark executors work. Then the Spark driver will interact with the Mesos master, and that will activate interoping work with the workers that will save the results to Hadoop, HDFS, or Cassandra, or something else. An operation example. A driver creates a job. The job issues multiple serial and parallel stages. Each stage has multiple tasks, and each task is assigned to process partitions of the RDD within the node's executor. Mesos master schedules the task that the executor will run on the partition. For a Mesos master scheduling process, the schedule is determined based on these following factors: the remaining resources on the node, the executor processing capability of the cores on the executor, the number of short-lived tasks and long-lived tasks, the estimated processing duration of the short-lived tasks and the long-lived tasks, what other frameworks coexist on the cluster that are being operated now, and the potential schedule of dynamic partitioning of the resources. Mesos client mode operates in the following way, where the driver shell program of Spark Mesos is launched on the client's computer. The driver can interactively monitor and control the process. The final resulting RDD dataset is displayed on the client's driver and saved on the SSD or HDD, which could be like HDFS. In cluster mode of Mesos, the driver is launched in the cluster on one of the nodes. The MCD, the Mesos Cluster Dispatcher shell driver, is started on a node in the cluster. The final resulting RDD dataset is displayed on the Mesos web UI. Zookeeper can be used for failure recovery, where the Mesos supports writing recovery state into Zookeeper. Mesos run modes include a coarse-grained mode. The executor size determines configuration variables, where memory size of the executor and the executor's number of cores and core processing capability are considered. The number of executors is based on statistics of the application. The coarse-grained mode has very little startup overhead. Mesos resource allocated to the application cannot be changed until the application is over in the coarse-grained mode. On the other hand, we have the dynamic allocation mode. And just from the name, you know that there is more dynamic adaptability. Mesos supports dynamic allocation with the coarse-grained mode. Each job is dynamically configured based on required and available resources that the executor has. These are the references that I used, and I recommend them to you. Thank you.